Hello, it's TK. In this video, we are going to calculate arc length in R2. So let's start by doing just a rough sketch of R2, just a rough sketch. So let's see. So now we're going to have our Y axis and our X axis. So let's just draw a rough sketch, just a rough sketch of R2. So we have this is our Y axis and this is our X axis over here. Okay, just a rough sketch. Now, suppose that we have a curve here. Okay, suppose we have a curve. And suppose that our curve, just a general curve. Okay, so this is our curve here. And now, suppose that we label our curve C. So the label for our curve is C. And also suppose that the equation of our curve is y is equal to f of x. That's the equation of the curve. And also, let's suppose that the parametric equations for this curve are given by the following. So this curve has the following parametric equations. X is equal to xt and y is equal to yt. Okay, and suppose that the range for t is a, so t is between a and b basically. Okay, let me just write that again. Doesn't look good. So there you go. So this is our rough sketch of our curve in R2. The label for our curve is C, equations y is equal to f of x. And this curve also has parametric equations, x is equal to xt and y is equal to yt. And t is between a and b. That's the range for the parameter t for this curve. So therefore, now we want to calculate the arc length of this curve. Now to calculate the arc length of this curve, we need the metric for R2. That's where we start. We start with the metric for R2. Now, in a previous video, we did discuss how you derive the metric for R2. So the metric for R2 looks as follows. This is what it looks like. Okay, let's write down the metric for R2 because we need that in order to calculate the arc length of this curve C. So the metric for R2 is the following. ds squared is equal to G. Okay, let's go back. So the metric for R2 is given by the following. It's given by ds squared is equal to dx squared plus dy squared. So that's the metric for R2. Okay, so that's where we start then. Now we've got the metric for R2. So now to move forward, what we need to do is we need to introduce the parameter t into the metric in order for us to derive an expression for the arc length for the curve C. So the way we do this is we divide both sides of this metric by dt squared. We derive both sides of this metric by dt squared. So that's how we introduce the metric. That's how we introduce the parameter, rather, into the metric for R2. So this implies the following now. We divide both sides of this metric by dt squared. So we got ds squared on the left divided by dt squared. Okay, on the left we have ds squared divided by dt squared. On the right we've got dx squared divided by dt squared plus dy squared divided by dt squared. So we divide both sides of this metric by dt squared. That's what we just did. So what we just did is we divided both sides of this metric by dt squared. And this is what we get. So moving forward, we say this implies the following. So now ds squared over dt squared, we can write it as ds divided by dt. Okay, ds squared ds squared over dt squared, we can write it as ds over dt all squared. We can write it like this. And the right hand side, dx squared over dt squared, we can write it as dx over dt all squared plus dy over dt all squared. So we can write it like this. Okay? And then now, the next thing we do is the following. We can now we can square root both sides of the equation, so that we can cancel the square root on the left side. That's what we want to do, really, because we want an expression for the arc length. So the next thing we can do then is square root both sides of this expression. And if we do that, we're going to get the following. We're going to get ds. So if you square root ds over dt squared, you're going to get ds, because the square root and the square is going to cancel out on the left, and you're going to get ds over dt is equal to the square root of dx. Okay, let me write that x again. So we got dx over dt squared plus dy over dt squared. So that's what you get basically when you square root both sides of this expression. So now you're here. So the next thing that we want to do now is just multiply it throughout by dt, because we want to have ds on just ds on the left. So we multiply it throughout by dt, and we get that ds is equal to the square root of dx dt squared plus dy dt squared multiplied by dt. So now we have an expression for the arc length of our curve C. Now we have an expression for the arc length of our curve C. And this expression it's a general expression, because our curve C is a general curve in R2. Okay, and this is ds. So this is what ds is. ds is basically the infinitesimal arc length for any part of C. So, for example, ds is the infinitesimal. So this can be ds here. Okay, basically it's the infinitesimal arc length of any part of the curve C. That's what ds is. It represents the infinitesimal arc length of any part of our curve C. All right. So therefore, in order to calculate the total arc length of our curve C, we have to integrate ds. So to calculate the total arc length of our curve C, we have to integrate ds over the whole range of the parameter t. Okay, so let's do that. Okay, so we say therefore the length, we're going to denote the total length of C, we're going to denote it with an L. Okay, so L denotes the total length of the curve C. Okay, so the total length of the curve CL is given by the integral from A to B of the infinitesimal arc length of our curve C, which is ds. So we have to integrate ds from A to B to get the total arc length of C. Okay, now obviously this is equal to the integral from A to B of this square root of dx dt squared plus dy dt squared. All right, dt. So you basically integrate this from A to B to get the total arc length of our curve C. All right, you integrate from A to B, and you're integrating ds, which is given by this. So that's basically how you do it. So therefore, this is our final result. Okay, this over here is our final result. This is the total arc length of our curve C. The total arc length of our curve C is given by this integral here. Okay. Now, this curve C obviously is a general curve on R2. It's a general curve on R2. So this is basically the formula that you basically use to calculate the arc length of any curve on R2. Okay. Now, we're going to stop this video here. We're not going to discuss a specific case where we calculate the arc length of a specific curve in R2. This was a general case. But in the next video, we are going to discuss calculating the arc length of a specific curve on R2. And we are going to use this particular formula here that we derived. So for this video, we are going to stop here. Thank you for watching the video. If you like the video, press the like button and subscribe to the channel. If you have any comments or if you have any questions for me, you can comment in the comment section or you can send me an email.